Hey guys, in this lesson, we would understand how to complete the square. Let's understand what is the meaning of completing the square first. We have already learned in the previous unit that there are three different forms of quadratic relations or equations. One is called standard form, the other is vertex form, and the third is factored form. We have already learned in the previous unit that we can turn standard form to graph using table of values. If the numbers are big, then table of values is difficult to make so as to get a symmetrical parabola. That's why turning a standard form of quadratic relation into a graph is a little bit complex job. If we want to turn a vertex form to graph, then we can either use transformation table of values method, or the easy method is step pattern. And if we want to turn a factored form into a graph, then we first get the zeros from the factored form and we get vertex. So the two zeros and vertex are good enough to turn the factored form into a graph. Now in this unit, we would focus on how to convert one form of quadratic relation into the other form and what are the different application problems of quadratic relations. This completing the square is a method that helps us convert standard form of quadratic relation to vertex form of quadratic relation. Therefore, the process to convert the standard form of quadratic relation to vertex form of quadratic relation is called completing the square. Now, when is completing the square is going to be useful is when the question is given to us in standard form. However, the demand of the question is to find the maxima or the minima point. We know from standard form we cannot read the maxima or the minima point or the vertex or the zeros. So remember, from the standard form we cannot read vertex or zeros or axis of symmetry. So if we are given the standard form of quadratic relation and the question wants us to find out the vertex or zeros or the axis of symmetry, the best way is to complete the square to convert standard form to vertex form. And once we get the vertex form, then we can read vertex and the axis of symmetry. There is also a procedure to convert standard form to factored form. And in the factored form, when we can read the zeros easily. So from the vertex form, we can easily read vertex and axis of symmetry. However, from the factored form, we can easily read zeros or roots or eccentricities of the equation or the graph, and we can obtain vertex as well as axis of symmetry. Therefore, whenever the questions are given to us in standard form, it's always the best way to convert the standard form either to vertex form or the factored form to get the necessary things demanded by the question. Let's first understand what is completing the square and what are the steps we need to follow in order to complete the square. Now let's say we're given the first question that wants us to determine the vertex and axis of symmetry of the parabola obtained from this equation. We know this is the equation of a quadratic relation. And since the quadratic relation general equation for standard form is y equal to ax squared plus bx plus c, and this equation matches this equation. So this is given to us in standard form. Now we know we cannot read vertex and axis of symmetry from standard form. However, if we convert the standard form to vertex form, whose general equation is y equal to ax minus h squared plus k, then we can read the vertex because we can read hk, and we can get the axis of symmetry from the equation. So our first step is to convert this standard form to this form or the vertex form, and that is called completing the square method. First step to complete the square is factor a out of ax squared plus bx from the given question in standard form. So in this particular example, the equation that we are given in standard form is y is equal to x squared plus 8x plus 5. We notice we are not given any a there, so a is 1. So the first step is to factor this a out. So 1 is factored out of ax squared plus bx. Because it's 1 that is factored out, inside the bracket we are left with x squared plus 8x itself. This plus 5 will stay outside the bracket, as a has only been factored out of ax squared plus bx. Step number 2 is divide the b value in the bracket by 2. In this example, we have y is equal to 1. X squared plus 8x plus 5. So b value in the bracket is 8 and we divide it by 2, we get a 4. If we are unable to completely divide by 2, we can leave it as a fraction. However, we do not need to change it to decimal. But in this case, we are able to divide 8 by 2 so that we get a 4. And that is the answer for step number 2. Step number 3 is square b by 2 obtained in step 2 and add and subtract b by 2 square inside the bracket. So in this particular example, we know b by 2 we got was 4. We square 4 and we add and subtract this 4 square inside the bracket. The number outside bracket is plus 5. That would stay as is because we have done nothing to it. And this is how now the equation looks like. Step number 4 is multiply a and negative b by 2 square and bring it outside the bracket. So we would take the a value, that is 1, multiply it with negative b by 2 whole square, that is this negative 4 square, and we have brought it outside the bracket where we already have plus 5 written there. Nothing has happened to plus 5. It stays intact there. The only thing is that we have multiplied a and minus b by 2 square and we have brought it outside the bracket. Everything else in the bracket will stay as is. Step number 5 is solve the operations outside the bracket. However, numbers inside the bracket stay as is. This is how it looks like. Y is equal to 1. X square plus 8x plus 4 square stays as is inside the bracket. And when we solve all these operations, we know BEDMAS goes first. So this is going to be squared first. We get 1 times 4 square is 16. Remember, the square is just on the number. It's not on the negative sign. And that's always the case. Plus 5. The next thing we would be doing is multiplication before we add these up or subtract these up. So 1 times negative 16 is negative 16 plus 5. And now we would add negative 16 and 5 and we get negative 11. So this is the final answer that we get outside the bracket. Step number 6 is the last step. And step number 6 is write the final answer inside the bracket as outside the bracket value has already been solved. And how do we work inside the bracket is a would stay as is, that's 1. Everything that has a square would come inside the bracket with the square outside on top of the bracket, and this plus sign or the sign that this bx value has would come in between these two terms. We had negative 11 that was already solved in step 5. That would stay outside. And here we notice that we've got our answer in y equal to a x minus h square plus k form. Therefore, the standard form of equation now looks like vertex form, and the answer that we've got for this particular question is y equal to 1 x plus 4 whole square minus 11, and that is y equal to 1 x plus 4 whole square minus 11. That's how we are able to change this standard form to vertex form of equation. Now, if we want to write on the vertex, we know vertex is hk. H is this, k is this. H is always taken with the opposite sign. So it is negative 4, k is negative 11. That's our vertex. And axis of symmetry equation is x equal to the h value, and that is negative 4. This is how we get the final answer. And we saw that reading the final answer from the vertex form is very easy. It's just that we have to know how to change the standard form to vertex form using completing the square. All of these steps that we have followed in order to get this form is part of completing the square. Let's quickly take up another example for the sake of practice. In this question, we are given y equal to negative 3x squared plus 12x minus 13. This equation is in standard form. If we are supposed to convert this to vertex form, we would have to do completing the square. We know step number 1 is to factor a out. So when we factor a out, a value is negative 3 here, and we always factor a out of ax squared plus bx. So when we factor negative 3 out, from this term we are left with x squared. However, from this term we are left with minus 4x. And how do we get this? Is we take the number given to us in the question, that is plus 12, we divide it by a value. So when we divide plus 12 with a, which is negative 3, we get a negative 4. That's the new b value inside the bracket. And outside the bracket, negative 13 stays as is. Second step is we take the b value, just the b value, not sign, divided by 2 to obtain b by 2. So b by 2 value that we've got is 2. Third step is we would square this b by 2 value and add and subtract it inside the bracket. So the b by 2 value that we obtained in step 2 is 2. We would add and subtract this value and put it inside the bracket. Fourth step is we would leave everything from the first 3 terms inside the bracket. However, we would multiply minus b by 2 square with a and bring it outside the bracket. Step 5 is we would simplify the operations that are outside the bracket. So first we would be solving the exponent. It's minus 2 square. So 2 square is 4. So we get minus 4. Now we would multiply. So we get a positive 12 minus 13 and we get here negative 1. That's the answer to step 5. Step 6 is to write on the final answer working with the numbers inside the bracket. So outside the bracket we have a as negative 3. That would stay as is. And minus 1 behind it, that would stay as is as well. Inside the bracket, everything that has a square on it, we would write on those terms. And sign, we would pick up from the middle term. So it's minus. Because we took the square term, so square will become a common square outside the bracket. And this would give us the final answer. That is in the form of y equal to ax minus h square plus k. Now, if we were asked to write on the vertex for this given question, we know vertex will be 2, negative 1, hk. And if we were asked to write on the axis symmetry equation, that would have been x equal to 2. Because axis of symmetry is x equal to h. And that's how we complete the square and convert standard form to vertex form in order to obtain vertex and axis of symmetry directly from the equation.